Hello, Coach Holmes here, and today we're going to be talking about kites. So, y'all kind of know what a kite is. It's one of those things that you actually fly and let it hang in the air when the wind blows. But as a shape, it has a unique feature to it. There's something unique and different about a kite that makes it work. A kite is a quadrilateral with exactly two distinct pair of adjacent, not with a G, adjacent congruent sides. So what does that mean exactly? Well, first off, it's kind of like a diamond. But it basically means since these two sides are adjacent, they're going to be congruent. So then the other two will be congruent as well. Alright? It just has to have pairs of adjacent congruent sides. Now, what does adjacent mean? It means they touch. Okay? That means they're touching at one point. So for example, AB touches BC and AD touches DC. Those are going to be congruent. Now we can do it any other way, but they have to be adjacent, which means they touch, and those pairs have to be congruent. And it has to be both, okay? You have to have two pairs of adjacent congruent sides. Now, we're mainly going to be talking about theorems for this, but I also want you to recognize how these images or how these theorems look. So for example, one theorem states that the diagonal of a kite is perpendicular. So what does that mean? So if I draw, here's one diagonal line, here's the second, bam, I got a right angle in the middle. So if I look at it like that, I have a right angle, which means I have a pair of perpendicular segments, which again means I form a right angle. Now, another thing we gotta look at is that one pair, not just two, but one pair of angles is bisected. So this is for number one, this is for number two. So if I look at this, well, better yet, let me show you. So those are the congruent sides, okay? Those are the congruent sides. If I split the middle between those two like this, this is one pair of congruent angles, bisected angles, this is the second. Okay? Now, do they necessarily be the same? No, not necessarily. So, but the biggest thing is that this diagonal line where it kind of splits these two in half, those are going to give you bisecting angles. Now, let's look at the third theorem. One diagonal is bisected. So what does that mean? Well, if I look at it right, so here's my congruent sides. This side right here, this diagonal right here are going to be bisected. So in this case, if one side is congruent and the other side is congruent as well, it's basically that diagonal line. That's how you have to look at it. One pair of diagonal sides are congruent, the other one is congruent. So that diagonal line that splits them into sides, that's the bisected diagonal. All right. It's kind of tricky. It takes a while to think about, but that's how it works. Next, we have one diagonal cuts the kite into two congruent triangles. Now, how do we know that for sure? Well, let's think about it. Here's a pair of congruent sides. Here's another pair of congruent sides. And I have a diagonal line right here. Think about it. That's congruent to itself. So by side, 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 we have two congruent triangles. That's how we get congruent triangles, because of side, side, side. All right? So anytime you have a kite, it can make two congruent triangles. And I want y'all to keep in mind about these theorems. That's the big thing I want you to keep in mind. The diagonals are perpendicular to each other. If I split the triangle in half where it has two different sides on one side and the other, the angles are bisected. If I have a diagonal that splits the congruent sides in one side to the other, that diagonal is bisecting, so that diagonal is split in half. And one diagonal line actually makes congruent triangles. And typically it's going to be the setup just like, it's going to be the same diagonal line just like number 2. And it's going to be congruent by side, side, side. Thank you and have a good day.